Welcome to BizQ's weekly online training series. Today's topic is on how to improve the performance of your report using the Analyzer report, presented by Neeraj Khurana. Neeraj has spent the past 4.5 years as a business intelligence developer and analyst for various companies and projects in which he was responsible for development and implementation of BI reporting systems. His specialty lies in detailed technical analysis of business requirements, where he communicates with clients to understand and implement new business processes, including collection of new data, report generation, and implementation of business rules. He has experience using ETL tools in process documentation and report preparation and distribution. Neeraj holds a Bachelor of Engineering in Electronics in Communication and a Master's of Applied Science in Information Systems from RMIT University in Melbourne. You can use the WebEx chat feature to ask questions at any time. Post questions to BizCube host, and our presenter will be answering questions after the presentation. Now over to you, Neeraj.
Hi, thank you for inviting me for the webinar. For this week, we're going to talk about how you can improve performance over when you're using Analyzer reports in Penthouse, or we're going to talk about some general data warehouse concepts that we can use to the performance of our reporting systems. Let me just bring up my slides in here. So that's going to be our topic, how we can improve the performance for our data warehouse system. Now, it's really common. So we're going to, organizations are constantly looking for ways to improve data warehousing, reporting, and business intelligence system. And data warehousing and BI performance improvements are becoming even more and more important as companies broaden the deployment of BI tools, include more tools and emerging concepts such as operational BI or real-time BI code. We see business users running reports and dashboards in everyday life. They use mobile, tablets, computers, laptops to run different kind of reports at different time of time. And sometimes it happens when you click on a report and you just wait. You wait for the data to come up. And sometimes we see the dashboard nice and quick, easy, but when you drill down and you look for the deeper knowledge of the data, when you scroll through different dimensions of different countries, your reports get slower and slower for no reason. Sometimes you wonder why, after spending so much money on BI and data warehousing system, we are still getting very slow reports. There is also a third scenario which is quite common when users do deeper analysis across different countries of different products, and then you talk about different dimensions, and you want to look at the data at different geographies. That also slows down your reports because of the query running at the back end. We're going to dig in detail in later on, and during this webinar we are going to talk about what data warehouse is not. I'm going to highlight some of the misconceptions that sometimes business users have about data warehouse, or system designers have when they actually architect data warehouse. And we talk about the performance bottlenecks. So what are the major stuff we should be worrying about, and why it gets slow, what are the reasons behind it, and how we can solve it. And then we're going to talk about some quick fixes. We're going to talk about what business users, what DBAs, and what system admins can do to improve overall performance of the BI systems. Let's start with what data warehouse is not. Now, every user, they definitely want faster speed on any device they use. They want to run reports instantly, and it doesn't matter what sort of machine they are using. They want to see the reports. Generally, you use a web interface. These days, we are using self-service BI tools that use web interface, and we want to see. We can go onto a type a URL and we can see the report instantly. But it doesn't happen in real life. We get slow reports, we get issues, we get errors, and let's not talk about it. So what data warehouse is not? It is not a data dumpster. Let me talk in detail about this. Every business, if you're in business and for like 10, 20 years, everyone has data. Now, most businesses have 10 years worth of transaction data. Let's just assume that. And if it is coming from the ERP system, now that does not mean that we have to bring in all of them into our data warehouse. So that is a primary mistake that most businesses do, is to dump everything from the ERP system, from their Excel files, or from their different systems into data warehouse, and we bring together everything in one place. And then we build history of 20 years and we try to report the data warehouse based on that. We rarely need to do any reporting using such old data. Part of the benefit of having data warehouse is to have only the clean data that you need, and that's why it's called data warehouse. It's not a data dumpster. So whenever we architect data warehouse, it is a very primary and a fundamental thing to consider how much data we need when we are building data warehouse. We can obviously build different tables for the history where we can keep transaction history in separate tables rather than reporting tables. So we always need to architect and think before we actually decide what sort of data warehouse we need, why we need a data warehouse, what sort of reporting and RSAs we are supporting. Second point is data warehouse is not a one-stop solution for all your reporting needs. I'm sorry for that. So many business users assume that putting data together in one place will improve your reporting performance. It is not a one-stop solution. So we extract everything from Excel, text files, different ERP systems to store them in data warehouse, assuming this will solve all their problems, and we can run queries. Think of it this way: we have a relational database and we have a data warehouse system. What is the point of building a data warehouse if we are running the same queries compared to relational as well as the database? Only the structure, talking about different dimensions or designing a fact table, is not going to improve our reporting performance. There's a tip: build data architecture and data governance model. Clearly define what data is required and what is used, how often you want to access the data, and what data should be updated on a constant basis. Define data flow within the business and how it can be controlled. Think of a system as an assembly line. Now, what we do in an assembly line, we talk about one step to another step. It needs to be automated. Each step is easily accessible, and all links are complementing each other. Remember, chain is as strong as the weakest links, and that's what data warehouse system is all about. So extracting from data from source systems, still we use build our reports. Each and every step should complement each other. Each and every step should be built with a view to improve the performance of the business. Let's talk about performance bottlenecks. Two categories: data loading from source system into data warehouse, and data loading from data warehouse to reports. And this is how I see it. The whole data warehouse architecture is basically extracting data from the source system into the data warehouse, and then use of data warehouse system instead of our source systems to actually build reports and running analyzer reports in Penta or other tools, and to see build dashboards, and we expect it to be really fast. It does solve our purpose. We do some data cleaning and everything while on the go, but we need faster and faster. Let's talk about how we can build it faster. Now, when loading data from source systems, it is always helpful to analyze depth and breadth of what people are using. It is not a question of how many rows in a table. It is about how many dimensions, how extensive the analysis is going to be, how old the data required, how to access history when needed, how frequently the data is being loaded from the source systems. We need to answer all of these questions when we are designing our ETL. We need to answer all of these questions when we are designing our data governance model. We need to answer all of these questions when we are designing our data architecture. We should also take into account our system requirements, hardware we have to store the database, how to balance between transactional and our reporting database. We need to talk about our network performance issues. We need to talk about our networking speeds. We need to balance between the two to get the highest performance. We need to decide how much data we are reading and how much data we are updating on our data warehouse system. It also affects if you have a more reading from the data warehouse than updating, then obviously we need queries that suits your purpose. We need queries that do the reading more frequently than updating. Any sort of database have different queries. Any sort of database running query perform different kind of analysis internally that depend on the design of the query, whether we need it for the reading purpose or we need it for the updating purpose. I'm not going to get very technical about this. We can talk about this later. But before I go, there are three basic tips in designing a data architecture. Uh, when we define data information architecture, we always talk about stage data. We need to set up staging system in place. We need to set up stage data and set it up for specific three areas when loading. When loading data warehouse, tune in for loading only. Build a separate architecture when we are extracting from our source system into our data warehouse. Tune in only for the loading. Talk about bulk loading stuff. Let me show you something in our PDR which Mentor provides. Some of the steps which are called bulk loading, bulk loader, MySQL block bulk loader, Oracle bulk loader, or Postgres bulk loader, and we have other bulk loading databases and drivers as well, which comes as inbuilt. We can also write our own script for the bulk loading. This enhances your bulk loading facilities when you're loading from the source system into data warehouse. Tuning keep it as separate, and no one should be allowed to do reporting directly from these loaders, because this is basically you're only loading from source system to your data warehouse. Build data marts to suit specific needs and tune in to load specific type of information or department. That is where data mart comes in. That is the whole concept of the data mart in place. So after loading everything from source system, after applying all the cleansing, standardization, data standardization, extraction, transformation on all systems, when we load everything into our data warehouse, we need to build data marts out of the system that suits your specific needs. Set up your data mart to suit specific type of analytics and suit reporting or dashboard requirements, and this is linked with my previous point. It should be designed keeping in mind the analysis tool, the dashboard tool, or the query analytics tool we are going to use. We should keep in mind what sort of data is coming into the reports, what sort of data we are running our reports on, and the structure of the reports, and the data we need, how frequently the data we need, and a lot of questions needs to be answered when you're designing a data mart. A data mart should always be more specific and suits your day-to-day query, suits your business specific needs. Talk about this. We have a 10, 20 million rows in our data warehouse table. The data mart, you don't need to run a query over 10 million every time we run. Most reports we can answer using certain specific data sets. That's where the data mart comes in. So we can run and we can cache. We can use memory caching. We can build these small data sets to improve performance of our reporting. This is called divide and target strategies. People design cubes and data sets to answer every question in their business, and this brings down the performance of the database. Separate out types of analysis we are going to use, separate out types of data we are going to use in our different reporting, build data marts accordingly. There are many steps we can use to improve data load, such as in-memory analytics. We can talk about memory caching. We can talk about data visualization. We can talk about real-time loading within data visualization. We can control data flow after building data warehouse and how the data is actually flowing from data warehouse to the reporting. And we can control the amount of data based on the requirement in the report. We can control the type of the fields. We can control the type of and the size of the data types that we are going to use. These all small little steps improve performance on your database. It reduces pressure on the network. It reduces network usage and improves performance of the report tremendously. There are a couple of steps that Penthouse also put on the website, and they also recommend when you're building an analyzer report. We open up analyzer reports for you. So there's stuff that we can do on analyzer now. When you're building a new analyzer in Penthouse, we have certain things that that does matter. Now, when you're building a new report from any data mart, always remember to drop and drag and drop low cardinality fields first. Now, what are low cardinality? Is always refer to the columns with few unique values, like addresses, like customer names, like any string we are using, kind of notes we are doing. No cardinality column values are typically status types, flags, boolean values, or major classifications such as gender and other stuff. Example of data table column with low cardinality could be a customer table with a column name new customer. This column could contain only two digit values, yes or no. Now denoting whether the customer was new or not. So when you're building a new report, try to drag and drop because these low cardinality fields first on the report. We can always rearrange later, but that's how the analyzer works. That's how the Penthouse analyzer works. When you're running a query, it is much easier for a query to extract these low cardinality fields out of the database. It's much faster to extract. Then next we should be dropping all the measures. We should be dropping all the calculation measures. So because these are all based in the query, it's much faster for a query to run these. We can always analyze our query. If you open any analyzer report, we can go to here. If you're using Penthouse 4.8, we can talk about log or MDX. Any lower version of this always have on the top right corner we have log. We can see the logs, we can see the XML and the MDX. We have the options out. Now if you click on the log, it will open up this window. Now, if you see this window is actually giving us all the values that this analyzer is running and the time it's taking, number of rows it's extracting in each and every step. If you please look at this part, here we can see our capital fetch. So our extraction fetching is 4 bytes to 20 milliseconds, and we extracted only 3 rows. So that's a very slow query. Talk about it talks about everything in instance, and we can look into detail what kind of reports and are running slow, why they're running slow, what kind of typical queries we are running, and which queries are running very slow, and we can target those queries to improve performance of the reports. After dropping measures and the low cardinality, we always target high cardinality. Now high cardinality are basically all the fields that kind of all the remaining fields that have more unique values. Let's talk about, we talk about primary keys, we talk about ordinary keys. If we're trying any IDs, that those kind of stuff is always unique. After looking into these queries and everything in Analyzer, we can look into performance. Now, up till now, we talked about how to improve performance on our BI system by proper data architecture, control data flow, and building different data models to satisfy different business needs. Next, we'll talk about some of the more backend stuff. We talk about how to design tables. We talk about stuff we can do while designing database tables to improve performance and to improve query speed. We can start with indexing. Indexing plays a very important role in reading and updating data in tables. They are like the appendices in the backend. They help the database quickly find the data just as it's pending. Now, without an index, the database would have to be searched through every record in order to find the information that you are looking for in the query. And database administrators understand this, and they do use indexes, but it's possible over time they may need to add more indexes. They may need to update their existing indexes. Some of the fields may have indexes before, but now there's no need for those indexes. That overload the system. We need to continuously update those indexes as and when required, and we need to rebuild our indexes. We also need to work on what sort of data types we are using when designing tables. We can talk about the difference between NCAD, we can talk about CAD, VAD-CAD. It all makes difference. Every data type takes a certain memory usage when running a query. Suppose an intake 4 bytes of data. If your user IDs are really small, you can use tiny int to save memory for each query. If your number of rows are really big, we should be using big int. So these kind of small stuff, while building tables and everything, we can talk about date time, small date time or date time 2 issues where to improve this query performance. That's one of the stuff. Now, this concludes on my recommendation on how we can improve our report performance when building data warehouse systems. And before I finish, I would recommend following tips. Number one, decide on database and server system configuration. Decide how many people are going to use the system. What is the frequency of the reports we are going to use, amount of data, and the storage systems. Second, define data architecture for your business, how data flows in the organization, how it can be managed and controlled, how many steps it has to go through, and how many times it's been transformed. This also includes limiting data traveling between systems to use network speed effectively. Third, define data marts when designing data warehouse to serve business-specific needs and reporting requirements. Data marts are faster to query compared to data warehouse. Number four, how your business needs to handle history. How much history is required when reporting? How much history is required in your data warehouse? Number five, use of in-memory data visualization. Bulk loaders and loading, extracting, and transforming data using ETL. Less and less use of scripting steps also improve performance of the ETLs. And the last, how the reports are structured and the amount of data required in the reports, whether analyzer or dashboard, how caching is handled at the server level, how often caching needs to be refreshed. We can also load data in cache at times we are right now, so we do it in the morning and it comes out instantly. Data warehouse performance tends to degrade as more data is available to the increased data mining while important to business increases the overall load of the system as well. More people make use of the system also increases the load as large number of queries are made by the various words. Removing obsolete information means that the queries can be processed more quickly and return more relevant to them, making overall data warehouse maintenance an important part of data warehouse performance. It needs to be constantly checked. All queries need to be constantly checked. All indexes need to be constantly checked. And data warehouses are constantly building systems to improve, to reflect all your business needs on day-to-day basis. The last point, the infrastructure is another factor in data warehousing. It can be functioning at the highest possible level for available technology, but down the line in 1 year or 2 years, technology changes. More data moves in. We need more network speed. So improving data warehouse architecture, both on hardware and a programming level, can greatly increase data warehouse performance. Updating processors, additional storage space, using newer query protocols can greatly improve performance as well. In addition to these changes in overall data warehouse system can make a dramatic difference in amount of data that can be stored as well as the speed at which the process individual runs. With these tips, I would like to thank you all for listening to this webcast.